Today's Leetcode Weekly Contest basically. And so I open Substring. Let's get back to the contest and 1, 2, 3, 4. I think yeah. I think all problem were here. So yeah, let's start with the first problem. Count the digits that divide the number. You have been given a number n number num and return the number of digits that divides this number. 7 itself, hence 1. 1 to 1, two digits divide this like this by 1, but not 2. Hence the answer is 1, right? 1 occurs twice as a digit, we return 2. Okay. So basically you have to see all these digits like 121 and 1248, whether this number is divisible by 4 or 8 or this here. So how you can do this? You can store digits into that. Let's say D. I'll say if your num modulo D is equal to 0, I'll say Z plus plus kar do, right? And integer Z equal to 0 and return Z. Now the thing is ki how will you make this a D? That's also not a bit of a task because you have done that pretty well. So let's create a set of digits. Okay, the thing is you will not create a set over here. You want this 1 to 1 may the answer is just basically 1 2 times, so you will have to create a vector because repetition you have to take a D. And then while your num, let's make a copy of num, and temporary is equal to num, and while t exists I will divide t by 10 and I will add what is t modulus this d dot push back t modulo 10. I think that would be enough, and I have created my d. Then we will check this. Yeah, nums is not defined, nums and num. Yeah, let's try with example test cases. Run code. Operation error. Now modulo d. Okay, modulo d. No space in between. No. Modulo I think. Yeah. Okay, let's see. Yeah, 1 to 4. Let's try sum it up. Accepted. Let's move to problem number B. Distinct prime factors of a product array. You have been given array, I think, yeah. And then you have to tell distinct prime factors of the all the elements in this array. For example, for this array, what would be the answer would be? For this array, the answer would be 2k prime factors are 2, 4k prime factors are 2 and 2, right? But only 2 is, so 2 has already came, so we'll not count anything again, right? So we'll now move to 3. So 3 ka prime factor is 3, 7 ka is just 7. These are prime basically. 10k होते 2 and 5. 2 has already come, we'll just count only 5. 6k 2 and 3, both are already counted. So these are 4 basically distinct prime factors, ठीक है? कि बिकॉज दीज आर द फोर नंबर्स जिससे मिलके ये बने हुए हैं, राइट? इन्होंने यही पूछा है बस, थोड़ा सा दे हैव ट्रिक द लैंग्वेज बेसिकली, जैसे कि कैलकुलेट द प्रोडक्ट ऑफ द एलिमेंट्स फर्स्ट एंड देन देयर डिस्टिंक्ट प्राइम फैक्टर्स। बट प्रोडक्ट्स का फिर हम फैक्टराइजेशन करेंगे, इससे बेटर है कि वी फैक्टराइज ईच नंबर इटसेल्फ and then otherwise you can do, but no, I don't think you should do product because then it can go overflow. You can simply see a particular number, see its prime factor, add into a particular set, something like that, so that they don't get repeated. So that's what I did. Let me do it again. It was pretty very simple. I created set because to avoid repetition of the factors, and for see every number in this auto I in nums whatever been given, and see while now no basically now just do prime factorization for this I, and time complexity is not big issue over here. So yes, you can do like normal prime factorization like how we do key while your I is exists to something like that, and not like that basically, but you can do another for loop, something like that. For int I is equal to 2, say we'll start I is less than not I, basically you can keep it as j because I is the number, and j plus plus, and if your not if, just while, basically you have to take prime factorization like while it's getting divided by I is getting divided by j mod 0, we'll just keep on dividing I by equal to j, right? Okay, and we can just keep on inserting this j, but as the number is same every time, so only one occurrence will be there. S dot insert j, I divided by j. At last, you can return the s dot size. Yeah, let's try to sum this up. Okay, y1, y4. Basically, I wanted j equal to 0, I divided by equal to j. Hmm. 24376 nums 2 से लेके I think equal to you have to provide. Yeah, now 4. Because yeah, some prime numbers are just divisible by themselves. So for this accepted. So let's move to problem number C. Okay, it was a good problem. Partitioning string into substring with at most k. Yeah, we can do this. So basically, the problem statement you can read out, but they have said that you have been given a string s and you have been given a k, a number. You want, this string to partition into this, partition the string into some substrings, right? So let's say how many ways to partition it. Like there are obviously many ways because you can partition about any index, and it's not like how many partition you can create. You can create any number of partition, but we want to have minimum number of strings in a good partitioning of s. Partitioning is good if each digit is exactly part of one substring. Value of substring is less than equal to k. This is the main important condition. ठीक है? You have been given this number k. हम इसको partition करेंगे such that the substring which I am creating will be less than k, and then I want to return the minimum number of substrings to create that possible. So to make this possible and k is equal to 60, I can split it like that key, not 6 but 60, and 1 6 I can keep in 1 because I can't keep 1 6 and 5. The logic for this problem is just simple like that, like what I'm doing over here कि you have to start iterating from left to right, see कि कितना हम एक string में रख सकते हैं. 165 we can't keep, so only 16 we will keep, and then we will keep 5 and 4, and then we will keep क्या हम 6 to रख सकते हैं? No, so just 6 and 2 I think. Yeah, that's what the answer for this is 4. और एक और केस मैंने जैसे ये लिया था. So similarly जैसे 15622 है, हम लेफ्ट साइड राइट करना स्टार्ट करेंगे. 1 I can keep, okay, 1 5 I can keep, 156 I cannot keep because k is 60. 60 से छोटा होना चाहिए. ये इसकी बेसिकली स्ट्रिंग की वैल्यू बेसिकली 1 5 की वैल्यू 15 है, ठीक है. So that's smaller than 60. Now I have to create a partition. Now 6 will go in the next string. Up now 2 I can't keep together, so just create another string. So 2 and 2 I can keep. So basically these are the three good possibility, three partitioning that you want to create. तो greedy है, कुछ भी इसमें dp नहीं लगाना. You can get confused between कि should I write dp कि मतलब minimum number of, जैसे कि इन्होंने बोल दिया minimum number of आपको substring बताने हैं, तो आप you'll try to कि आपको डीपी का फॉर्मूला क्या हो सकता है कि डीपी ऑफ क्रिएटिंग 16 इनटू अ गुड स्ट्रिंग, राइट, एंड 61654 इनटू गुड. और इसका आंसर बेसिकली 1654 का आंसर हेल्प करेगा आपकी कंप्लीट स्ट्रिंग के अंदर. समथिंग लाइक दैट यू कैन क्रिएट, बट नॉट नीडेड एज ऑफ नाउ बिकॉज इट्स जस्ट अ greedy solution. You just start from left iteration and then let me do this for you again. And let's say int I is equal to 0 because you are starting from the 0th index. You will keep on iterating while I is less than s dot size. You'll keep on taking this into your string s. Let's say I create another string x, whose initial value is 0. I'll just do I have to just check one thing. If s of I is minus 0, if any character is basically greater than your k, means this is possible when k is just one digit number and your character is basically something like in this case 5 and 8 is there. So I just return -1 because in that case it's not possible. It's not a good partitioning because even if you create partitioning for this 8, this is not a valid partitioning, right? This, even this single digit 8 is not a valid. So that's why I'll say return -1. Now I'll do basically while you can keep it, right? While you can keep it means while your I is less than n and your string of ll लेंगे basically because the string length can go up to 10 की power 5. So 10 की power 5 basically like basically Yeah, your the string can be a very huge number, so this can be a string. This cannot be fit into the integer, so that's why string to ll. Your current string x which you are creating plus s of I, if you add this current number into your current string, something like when you have something like 5, it's still valid, but sorry, when you have k is equal to 60, and your string is just 1, it's valid. 1 6 is also valid, 165 is not valid. How will you see that? While your current x is, let's say, 1 6, and when you add this 5 to it, so the currently value is 116. Now currently value is 165. So you'll say when this value is less than or equal to k, I'll just keep on adding something like r plus plus, and I will be doing something like x plus equal to s of I, right? So that it gets updated also, and we are moving forward also, and that's what you need to do, right? um, hmm. After this you'll just make your string again, because now you see, okay, and now I need to create a partition. So let's say on 16 you have to create a partition, you will assign x equal to 0 again. So now the other string will start from 5, and whatever, let's say it was 5 and 4 was there, so 5 and 4 will start from over here. So that's why you have to initialize s equal to 0. Now you can return basically int z equal to, now you'll have to count the number of basically times you run this loop. You can just count it by how many times you went into this loop, right? And you can just return into that, basically how many times you created a new string x, how many times you created a partition. It's just z, and yeah, at least you want z equal to 1, so it will get 1. Let's try to sum this up. 0. Oh man, what is this? N is not defined. Okay, int n is equal to your string ka size. Thing else. Okay, and let's take example test case. This was actually a pretty big test case when I got error. Basically, I have to take stol. Initially, I was taking stoi accepted. So that's about it. Pretty simple problem. Don't need to mess around. You just need to go greedily and check iteratively how much string you can keep into one part. Till that, keep into one part, and then create a partition by doing this x equal to 0. You just need to check for this basic case that your one character should not be greater than k, otherwise you have to return -1. And that's about it. Count your number of occurrences you went in this loop, you created new partition, then return that. Okay, let's move to problem 4. Yeah, we can do this. And closest prime number in a range. This was actually a pretty simple question if you have done sieve before. So you have been given left and right two numbers. You have to find num1 and num2, two numbers in this range, such that those two number must be prime, and the difference between those two number is minimum. Left and right, basically nums1 nums2 in the range of left right, both are prime. The difference is minimum among all the other pairs, like obviously these are not the only two primes in this, right? So positive array answer equal to this, multiple pairs are then return one of them with a minimum nums value, or return -1 if it doesn't exist. When the doesn't exist, when the answer will not exist, let's say when when you don't have two primes, basically for example 10 to 9, there are multiple primes. Let's see how many primes are there between uh, 10 to 19, right? 10 to 19 you have primes like, okay, 11 is a prime, 13 is a prime, 17 is a prime, and 19 is a prime. Okay, so there are no other primes. So you have to see which two have difference minimum. 13 and 11 have difference of 2, 17 and 19 also have difference of 2. Which one you will return? You will return 11 and 13 wala, because the nums one is basically smaller. 11 is smaller than 17. Now let's say for example you have one or two, there are no primes in between, you have to return -1. So but the only thing is to generate primes, and that is basic implementation of sieve is basically used to generate primes. Sieves of Eratosthenes, you can see about over here, whatever the name is, but basically this is the way to generate primes, to do prime factorization and to deal with primes. Basically sieve has just common way. Let me just write for, and what I am doing with sieve over here, I'm just generating all the primes and storing it to a vector, right? In prime vector, and let's say void sieve sieve integer. I have taken like the number, basically limit where I have to generate the prime. So I will pass, okay, you have to generate prime till upper limit, because obviously these two numbers are obviously smaller than nums2, right? nums to right, basically these nums1 nums2 are smaller than right, so I have to generate all the primes up till right. So yeah, how I'll do that, it's pretty simple, like for int I equal to I less than n I plus plus, ठीक है. Before that you have to p dot resize something like n, and let's say 1. I'm treating, what does this p array means, like it will consist of 1. P of I equal to 1 means I is prime, ठीक है. And p of I equal to 0 means I is composite, not prime, ठीक है. I is not prime. That's what we do in C, right? So how to get this right? Initially we initialize all the number as prime. C works on the basis principle that we are cancelling out the elements which are definitely not prime, ठीक है. We know how many numbers are prime, how many numbers are not prime. We are cancelling out how many numbers are composite, not prime. So others will remain, like the number which will remain will be prime for sure, right? So let's say for 2 से लेके n I plus plus, we will say कि for int j equal to I square. अब basically let's say I can be any number, it can be prime or composite, ठीक है. So let's say I is equal to 2 or I equal to 4. तो 2 का square क्या होता है? 2 का square is 4 ना. So that's for sure would be composite, right? J is less than n and j plus equal to 2. This is nothing but, let me tell you, this is just a way to generate all the multiples of I. If prime, if I is your prime, you have to say कि your j is not prime, ठीक है. That's what you need to do. That's all what you need to do, right? So you have to generate all the primes like this. You have to initialize all everything as a prime. You will start iterating from 2 to n, basically the maximum value I square. Basically this is the way to generate all the prime, basically multiples of this I. When you generate all the multiples of I, you have to see if the I was prime, then the multiples will surely be not prime. Yeah, that's about it. Now you called on the sieve method. Now it will generate all the primes and store in this p. Now you have to see the primes in the range of L to R. Int L is equal to, not I equal to L, I less than equal to R, and these are all enclosed, right? Uh, Enclosed, basically equal to, greater than or equal to, less than equal to, right? So we can take L and R also if they are prime, okay? So I plus plus, if prime है तुम्हारा I, what you do, you just add it into some vector, let's say x, which I will use afterwards. And if x dot size is less than 2, means you don't get 2 prime, you will just return -1 or 0. What you have to return, also you have to return -1 -1 comma -1, this vector you will return, okay? And let's create our vector x, also your vector r for result, storing result, right? Now you will basically iterate on all the vector all through the vector x and see the difference. If a of I, not a of I but x of I minus of x of I minus 1 is minimum, okay, is less than your current minimum, you will say mn is equal to x of I minus x of I minus 1, whatever. But the thing is, what you have to do, key return, not return, basically r will get updated to something like x of I minus 1 comma x of I. This is basically those two primes which are having difference minimum, or minimum I will initialize by mn is equal to 1e9, something like that. And at last you have to return this r. Okay, so let's try this. What I did, I generated all the primes, then I see this range L to R वाला कि what all numbers are primes, by just doing this कि pi 1 है, इसका मतलब ये prime है, तो इसको push back कर दो. Then आपने उन सारे numbers पे basically जो आपने x array generate करा था, x array कि x1 x2 x3, यार these are all prime, और also these are sorted also, ठीक है. ये बताने की जरूरत नहीं है because I से L करके हम एक एक करके जा रहे थे, तो sorted order में ही आया है सब कुछ, right? Let's see इसका एक बार redefinition of r you cannot take. So what you can do, इसको हम x कर लें, not x, basically you can take it high, low and high, right? Low and high, low and high, low and high. I think that would be fine. N is not defined. What is n? N is nothing but x dot size. Okay, let me keep it like this. And I think it's basically not this. Let's see what is this. N plus 1 you have to keep it. N plus 1 because you are doing. Acha, I'm not doing equal to. You have to do equal to n also because your n can also be the answer, right? X and P of I. Yeah, yeah, yeah. You are checking P of I, which is equal to H. You have to, take P of n plus 1, right? Yeah, yeah. Oh, okay. Now what is this? Minus 1. Why it's not pushing back? I think there is some error in the sieve. No, J plus equal to 2, J plus equal to I. I think I talked example of 2. You have to generate all the multiples of I in this. Let's from I plus I, because then you will, do I also as a prime. That's not for sure. Yeah. Okay, runtime. Okay, integer overflow. Where? Multiple I am doing. Okay, I into I think. Line number 10, I square. So what I have to do? Should I take long? Okay, let's take long then. Because it should not be a problem. I'm just generating multiples. This I square is generating a problem basically. Can I do it like this? Let's see. Hmm. So let's do long then, using ll equal to long, and let's do ll elsewhere. Now it's giving something. Okay, 1 2. Okay, 1 2 is not. Acha, 1 is not prime. Yeah, देखो, in this case ना you have to do 1 is equal to 0. 1 is not prime, right? Yeah, accepted. एक बार let me just revise this. See if कोई मतलब you have to just know the implementation how to do this. For example, for integer पहले हम 2 से लेके सारे numbers के लिए check करेंगे, और फिर हम क्या करेंगे, वो जो ये नंबर i है इसके मल्टीपल जनरेट करेंगे, नॉट i इंटू 2 से लेके बट i स्क्वायर से लेके, ठीक है, फिर j प्लस इक्वल टू आई करते रहेंगे और इसमें हम मल्टीपल चेक करेंगे और हम बोल देंगे कि या if this is a prime then pj equal to 0. I think हम i से भी कर सकते हैं ना, i into 2 से कर सकते हैं, I into 2, but I think that would just give a time limit. Accepted. Okay, so yeah, I into 2 basically first जो multiple होता है i का, है ना, I into 2, फिर ऐसे ही plus i करते रहेंगे, I into 3, I into 4 and all multiples of I will do, check whether this is prime or not. If this is prime, then like I have to do, basically I'm generating the multiples now, so these multiples will surely be not prime, so I'll just do pj equal to 0, and for every prime number I'm doing this only, right? I'm not doing this for any number, I'm just doing it from prime numbers. And then sieve you will call basically, and then you have to, this implementation part is easy. Sieve you can refer also if you don't know somewhere, क्योंकि sieve is something to remember kind of thing, but this is basically implementation. You will see all the number, you will see if it is prime, we'll push back and then हमें sorted order मिल गया, हम उसका difference देखेंगे adjacent elements का, जो भी minimum होगा we will return that. Okay guys, that's about it. Today is contest weekly what 326, yeah, weekly 326. Okay guys, bye.